Hey guys, I'm a Science Potato, and today I've got a video on how to verify your 3D prints in Cura before actually printing them. So we have Cura open here. I'm going to load up a model. We got our benchy here. So say we went through our settings here. We're going to set these to default. And we're going to get ready to print, and we'll slice it. And now that it's sliced, normally our file would be ready to print. But how do we know what it's actually going to make? We haven't received any form of confirmation our print's going to be correct. So that's what we're going to check now. So we can either hit the preview button after we've sliced our part, or we can hit the preview button up here. And now it's going to take us into the visualizer for the G-code. So here we can see our model. Although this isn't actually the 3D model. This is our 3D model. This is a visualization of the G-code that was generated for your print. So this is truly what your printer is going to make. So we need to verify that it looks correct. So the first thing we're going to do is take a look at it from all sides. Make sure it looks good. We can zoom in real close. We can see the individual tool paths, all the individual lines it's going to make. Look it upside down, we can see the ceiling inside there. We got the windows and the doors and the portholes. You want to get a really good view so you can analyze all these features. Then we'll find a nice view where it's totally in our camera. And we'll grab this vertical slider here, and we can actually cut through the part. And now we can see our infill structure generating here. This is where we can check all the settings and what they're actually going to do. We can also go up from the bottom and look underneath if we need to. The most important thing to look at though is your very first layer. This is the layer that adheres to the build plate, so we want it to be correct. So we have different colors here. You can change your view type by clicking on color scheme. Normally it's going to be a material color, so it might be yellow, which is not very good. It all looks the same. It's hard to define it. You generally want to use line type. So the colors correspond to the feature type. So you can see red is our outer wall, green is our inner wall. So if we go to our shell, we can see we have 3 walls, meaning 2 inner walls and 1 outer wall. We can see yellow is our skin layers. So we got a few solid layers there before our infill starts, and we got some top layers there as well. We want to make sure there's a good surface area here. We also have a play button at the bottom, and we can watch it actually line by line draw out our part. This is good if we're trying to adjust our tool paths. And we can drag the slider to speed it up and scrub through it. It's very important to analyze these and make sure this looks correct. There could be errors in the model that you can't see, but Cura can see it, that can ruin the way the G-code's generated. And instead of printing the part only to find out it failed halfway through because of that, you can detect it here and potentially fix it. So there's a few things we can check here. First of all, we can see that there is a void here in this chimney. And the reason that void is there is because our line width is set to 0.5 millimeters, which does not divide into whatever the dimension of the thickness of this is. But we can adjust that. So if instead of a 0.5 mil line width, we use a 0.4, now anytime we change a setting, it's going to wipe the G-code, which is why it disappeared, but we just resliced it, now it's back. Now we can see with the 0.4 mil line width it'll fit in there. Then we go up to this chimney, the chimney top, and now there's a void in the chimney top as well. But if we go back to a 0.5, now we can see it's filled in the top, but the void's in the bottom. So we want to analyze all the different features of this to see how it's going to print. So here we can see that this box liner looks like it's going to print nice and solid. We can see at first here though, there's no infill on that layer, or sorry, there's no inner walls on that layer. If I click on my layer here, I can use my arrow keys to go up layer by layer very precisely. And I can watch how it slowly widens and more lines are put. So we can see there's 2 inner walls there. And as we go down, it squishes into one before there's a few layers where there's no inner walls there at all, which would affect the integrity of our part if that were a concern. But if we go to a 0.4, now we can see that very first layer of that box liner has 2 walls. And as it widens up, a gap forms in there. And another line can't be placed in there because that gap is not wide enough to fit whatever line width you've adjusted it to here. So if we changed our infill, we could see exactly what that effect is going to do. It makes it very easy to check your settings. If you're unsure what a setting does, you can change it, and then you can look at this view. Let's try 30% infill. There, now we can see how high that density has become. If we zoom in real close though, we can also see that it's actually doing one path per layer rather than both on the same layer, which is why the grid looks so dense compared to what it's actually set to. We can see all those voids there, which is because we're using a zigzag infill pattern. We could switch to grid. And now we'll be able to see the exact difference it's made. There we go. So now it looks much less dense, but if we look down and zoom in, we can see it's going both directions on each layer. So those are effectively solid walls all the way up. Oops. You can see there's a wide range of patterns here, so you can try all of them to see what kind of effects you have. We can turn on the gyroid, which is one of their newer infill patterns. You can see how intense that is. We can also check our layer height, because if we look at this from the side, we can see right here, this looks very steppy and coarse, because we have a 0.3 mil layer height. If we were to use, say, 0.1, we can visually see the difference that will give us. There, now that looks much smoother. And we can check all this before actually doing any print. We can see the ceiling looks much smoother as well. But of course our print time has drastically increased. You could also say set your line width to 1 mil if you're using a big nozzle. Now we'll see some real issues appear, because this model is too small to effectively print well with a 0.8 mil nozzle, or sorry, with a 1 mil line width in general. So cutting through it, we can see that most of the walls appear to be close enough together that they'll bond properly, especially down here. You can see how it separates. And it's bound really close together as it pulls up. So actually this looks like it should print all right with these settings. You can see here that these walls are totally solid. There's a couple little gaps, right there, right there. That's not a big deal. But as long as these walls are touching, we know this is going to be good. If I set this to 0.8 instead, we might see a gap form between those walls. And that's what we don't want. That's what we're looking for. We want to find those problem areas and resolve them. Because now this is going to be very weak and fragile. None of these are connected together. And same with these walls here on the front of the boat. You can see there's gaps there. All along the side here we have these big gaps, and that's going to ruin the integrity and the strength of our print. So by visualizing this layer view, we can find and correct all these issues. And all of these settings here have some effect on this. So it's very easy to figure things out if you're not sure what it does. Like on build plate adhesion, we got our skirt turned on, which is this light blue line. I could set that to a brim and slice it and see what that does instead. So now we can see our skirt has changed to a brim connecting all the way to the part. So we can look at it and confirm that that's what it's going to do. We can also visualize our support and how it's going to generate just by enabling it. And we'll just let Cura slice that quickly. Now we can see it's generating support inside the cabin of the benchy. You can see it's trying to support that roof there, although it doesn't actually need this support material. And that's important to note. You need to decide what parts need support and what don't, even though you might think this does, because there's nothing under there. It's such a small area, it's considered a bridge. It's a straight line connected on both sides, so it should print fine. You can also click on these buttons here to help us see and visualize things better. So I turn the walls off, I'll turn the support off. So now we're only looking at the infill being generated in this part. So there's not a lot of infill in there. Really, if we wanted to optimize, we could remove this little bit of infill up here because it's just unnecessary. Or if we want to see a void here, we can turn our infill off, and now it looks like a void. It's important to remember that you've done this, though, so you don't think that a setting is wrong when you've just hidden the ability to see it. There are other ways you can visualize your part. We can visualize it via Feedrate. So now the colors correspond to the speed it is printing that feature at. So here we can optimize our print time if we wanted, maybe speed up on this chimney because it's slow. Which we wouldn't though, because it's very small and it would heat up. So we want it to print slow, which is why it's blue. You can also visualize it via layer thickness. Now by default, Cura only uses a single layer height, but we can go all the way to the bottom under experimental here, and we can turn on use adaptive layers. Now it's going to change the layer height based on the angles of features on those layers. So now the colors correspond to the layer height it's printing these features at. Most of it is blue, going to be 0.2. You can see though there's a few areas here where it's mostly straight, where it's going to print faster. And we have a lot of settings here we can use to tweak these values if we need to, but that's a separate video. Now we're going to set back to our default profile. We'll hit slice. And we'll just check our default settings and see how it looks. We've already gone through everything, so we can give it a quick swipe. We know it's going to print good. The inner walls here, they're all touching. Everything's merged together well. And aside from this little void right in here, we don't have an issue. if you do need to tweak light values like that, there's a setting in the shell tab here called horizontal expansion. You can use this to adjust fine tolerances. You can see mine is set to -50 microns. So that means every dimension on the X and Y axis is being reduced by 50 microns to compensate for thermal expansion, stuff like that. You can do a print and tweak this value to get your tolerances set really tight. So I could tweak this value to try and get a material inside this void. So because that void's there, it's too small, so I need to make it bigger. So instead of -50, I'll go +50 microns in size. So we should see about a 0.1 millimeter total increase in the void size. And now we can see that it has filled in some of that void anyways. It appears to trickle out there. So we might have to go a little bit bigger to get all the way down. And now we can see that void is completely gone and filled with an inner wall. Alright, I hope you enjoyed the video. Please like and subscribe. I make a lot of content just like this for 3D printing. I also do design commentaries as well. Alright, thanks. Bye.